This one's called Vacuum Decay, and I don't have any time to get into all the details of it, but it's a really cool idea that it's been around since sort of the 70s, but it's gotten a lot more prominence recently with the discovery of the Higgs boson at the Large Hadron Collider. This is an event display from the Large Hadron Collider. They smash protons together, they look at what comes out, and they found the Higgs boson, which is like the final missing piece of the standard model of particle physics. And it tells us about how the laws of physics changed in the very early universe and set up all of the physics that we see today, all of the ways that particles interact with each other, and why atoms can exist, and why we can exist, and what the constants of nature are. All of that was set in the very early universe by some process that had to do with the Higgs boson. Unfortunately, that discovery also told us that that process, that the change in physics that happened with the Higgs boson in the very early universe, maybe it could happen again. And we really don't want that, because we like our atoms as they are. We like the laws of physics as they are, because they allow us to exist as solid objects. And they allow matter to hold together. And we don't want that to change. But apparently, there is this very slight chance that somewhere in the universe there could be a quantum tunneling event in the Higgs field, this energy field that fills all of space. And that quantum tunneling event could occur in one spot and create a bubble of a new kind of space that's called a true vacuum. It's not a true vacuum in the sense of being empty. It's more about sort of the real background state of this universe if it is unstable in this way. And that true vacuum state would contain sort of different laws of physics, different constants of nature. And so if you were inside that bubble, you could not survive. Absolutely not. And that bubble would have this sort of bubble wall that would be extremely high energy. So if it comes at you, it would incinerate you immediately. And then you're inside the bubble and you fall apart. And that bubble wall is moving out very quickly. It's moving at about the speed of light. So if you're standing nearby, there's no way you're going to see it coming. Right? By the time you see it, it's on top of you and you've been destroyed. So this is a calculation that was first done in sort of the 1970s when we didn't even know that we were going to find the Higgs boson, but the possibility was in the air. And there were a couple of theorists who wrote a paper in 1980 exploring this possibility. And when they wrote this paper, they calculated not only would this bubble exist, but the space inside the bubble would also be gravitationally unstable. So as soon as, so first you get incinerated, and then you're inside and you get torn apart, and then you collapse into a black hole. And they did this calculation, and then they wrote a little reflection on it that I'm going to share with you, because it's one of my favorite pieces of physics poetry. So they did this calculation, and then they said, this is disheartening. The possibility that we are living in a false vacuum has never been a cheering one to contemplate. After vacuum decay, vacuum decay is the ultimate ecological catastrophe. In a new vacuum, there are new constants of nature. After vacuum decay, not only is life as we know it impossible, so is chemistry as we know it. However, one could always draw stoic comfort from the possibility that perhaps in the course of time, the new vacuum would sustain, if not life as we know it, at least some structures capable of knowing joy. This possibility has now been eliminated. So I just want to end by saying I don't want you to worry about vacuum decay, because people do worry about vacuum decay, and I do get emails about it. And I just want to say, so there are a number of reasons not to worry about vacuum decay. One is that, what are you going to do, right? You can't do anything about it. Another is it would be so fast. It would happen at the speed of light. Your nerve impulses don't travel that fast. You wouldn't feel it. You wouldn't see it. You wouldn't notice it. You're not there anymore, and that's presumably fine. There's no tragic aftermath. There's no FOMO. Nothing is left. It's very clean. But also, when people do these calculations, they don't know, you can't predict exactly when or where a quantum tunneling event will happen, but you can predict a tunneling rate. You can predict what the decay time of a universe like ours might be, and those calculations tend to give us something like 10 to the power of 100 years. or maybe 10 to the power of 500 years.